5.3 talks about the sum and difference identities. In this section, we're going to use formulas that involve sum and differences to verify identities. And so they give us 6 formulas here. So let's look at the column on the left, the sums. The first one says sine of alpha plus beta. So we're taking sine of 2 angles being added together. We can set that equal to, we can say that that's sine of our alpha plus sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Then we have underneath that cosine of alpha plus beta. If we're taking the cosine of 2 angles being added together, we can separate them so that it's equal to cosine of alpha times cosine of beta minus sine of alpha sine of beta. And then we have tangent of alpha plus beta. So that would equal tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent beta. And then in the differences column, I'm going to go ahead and read through those as well because we're going to talk about some of the things we see here. So the first difference we have is sine of alpha minus beta. So we're going to take sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Notice the only difference between the sum and the difference there is that we're adding alpha and beta on the sums and we're subtracting them in the difference column. And so our formulas are exactly the same except the sums, we add them, and the differences, we subtract them. Then below that, we have cosine of alpha minus beta. That's equal to cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Let's compare that over to the cosine of alpha plus beta next to it. Okay, so, and cosine of alpha, notice both of the formulas have cosine of alpha, cosine of beta, sine of alpha, sine of beta. But when we're doing the sums, when we're taking alpha plus beta in the formula, it's a subtraction sign. And in the differences, when we're doing alpha minus beta, notice in that longer formula, there's a plus sign. And then the last one there in the difference column is tangent of alpha minus beta, and that's equal to tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent beta. Again, comparing it to the sum formula that has the exact same pieces, just notice all of the signs changed. So when we were adding alpha plus beta, we added on top and subtracted on bottom. But when we were taking the difference there, when we took alpha minus beta, we subtracted on top of the fraction and added on the bottom. So it says, what patterns do you see that could help you memorize these formulas? Well, you don't have to memorize these formulas because you know that you can put them on your unit circle. All right? But something that will help you there is, what did we notice about the sine when we did sines? So sines keeps the operation, meaning if it was alpha plus beta, then we added in the formula. If it was alpha minus beta, then we subtracted in the formula. And it alternated sine and cosine. Because it was sine of alpha, cosine of beta, either plus or minus cosine of alpha, sine of beta. Okay, so it alternated. So what about cosine? What did you notice on it? Well, cosine changed the operation. So if we're doing the sum, our formula is going to have a minus in it. If we're doing the difference, our formula is going to have a plus in it. And it kept the trig functions grouped. So, and groups sines and cosines. So what I mean by that is it was cosine of alpha, cosine of beta, either plus or minus sine of alpha, sine of beta. So it kind of grouped them together. Okay, it left the sines together, it left the cosines together. All right, and then we had talked about tangent. On tangent, it keeps the operation in the numerator. And changes the operation in the denominator. Alright, so like for tangent, it was alpha plus beta, then it was a plus sign on top. It kept operation in the numerator, but it put a minus in the denominator. All right, so maybe that'll help you some. Also, though, just knowing those kind of helps you when you're looking at which formula am I going to use, especially like here on example 1. So let's look at it. It says find the exact value of cosine of 70 degrees times cosine of 40 degrees plus sine of 70 degrees times sine of 40 degrees. All right, so the first thing you notice is you got cosine, cosine, plus sine, sine. All right, so which one of our formulas there has that pattern? Which one has your cosines grouped together and your sines grouped together? Well, that's a cosine. Okay, so it's going to be either sum or difference of cosines. Now, which one? Well, cosine, which one has a plus sign in the middle? The one that says cosine of alpha minus beta has the cosine in the middle. Has the plus sign in the middle. All right, so which one's your alpha, which one's your beta? Remember, your formula says, I'm going to write it over here though, cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. So look, what's in the alpha spot? The first angle. So it's 70 degrees. So this here then is going to equal cosine of alpha, which we said is 70 degrees. We said minus, well, what is beta? Well, check for beta here. Beta is the second angle there, which is 40 degrees. And then we can work that out. What is 70 minus 40? 30 degrees. And that's an angle that's on our unit circle. So therefore, we can figure out what cosine of 30 degrees is by using our unit circle. Remember, cosine is what? Your x or your y value. It should be your x value. So look at 30 degrees and tell me what your x value is. You should have the square root of 3 over 2. And so that is our solution.